Hey, Zed here. Welcome to my YouTube channel. In this video, we will see how we can store our application's credentials in a centralized and secure way using AWS Secrets Manager service. Also, we can update these credentials in an automated way to enhance application security. Let's say you have an application code base and want to deploy it on AWS Compute Infra, either using an EC2 instance, serverless Lambda, or Elastic Container Service. In this case, during deployment and before running your application, you would create environment variables like API key so that your app can function properly. But it's not a good choice to set this environment variable manually each time. To rescue, our cloud engineer proposes a solution to create a .env file which contains the name and value of all environment variables required for our application to run. This is still a good way to centralize the .env file by placing it in a S3 bucket so that it can be accessed from anywhere. But the drawback is that it still needs manual intervention if any credentials value needs to be updated later at some time. In this regard, AWS provides Secrets Manager, a managed service to facilitate the deployment process of our application in terms of storing and securing app credentials in a centralized way. Our cloud engineer will just have to add a key value pair like API-key with corresponding 256-bit long string as value, and our deployed code will just have to call AWS API to access this key dynamically whenever needed. Now there is no need to manage different versions of .env file in S3 bucket. The benefits of using Secrets Manager are significant. You can create, edit, access all credentials from a single platform, you either using AWS Console, CLI, or just by an API call. Plus, it provides additional security features to rotate the value of a credential with time scheduling. For that, you will have to attach your Lambda function, which will create a new value to be replaced by an existing one. Also, you have more control with regards to who can access which credential because each key value pair can have separate fine-grained access policy using IAM, which is very convenient. Let's do it practically. Make sure you are working in North Virginia or US East 1 region from the top right menu bar. Let's head over to AWS Console and open Secrets Manager. Click Store a new secret. Choose other type of secret. Type in key name, for example, API-key, and paste your secret value. Click next to move to next screen. Add details where or how it would be used. Type in a relevant secret name so that you can use it whenever required. Add some description as well. You can add tags to distinguish between multiple stages deployment like dev, QA, staging, and prod. And click next. It will display rotation schedule configurations which we can skip for now. Let's move forward by clicking next. On this screen, it will just show you configuration summary which we selected previously. Review them to make sure you didn't made any mistake. Here, sample code in different programming languages is also given for developers to access this secret inside their code base. Now hit store to complete the process. Now our secret is successfully stored. Just press refresh button to see it. On the console, head over to IAM service. And click policy from the menu on the left side. Click create policy. Then click choose a service. Type secrets and select secrets manager from the drop down. In actions, check the read option. Click on resources to expand. Click add ARN and type your region hosting our secret, which is US East 1. Now click list ARNs manually from top. Go back to the secrets manager service, open your secret and copy secrets ARN. Paste this ARN in the text field, click the add button. You can add some conditions here as well, but that's optional. Hit next tags. Add some tags for reference and it's optional. Now click next review. Enter this custom policy name. I am naming it secrets underscore manager underscore my app underscore dev underscore read underscore access and click create policy. Our custom policy is now created successfully. Now head over to roles and click create role. Select AWS service, choose Lambda and hit next. You can see our custom policy on top of the list. Select this custom policy and scroll down to click next. Name this role to role underscore lambda underscore myapp underscore read. And add some tags. Click create role. Review the summary of role creation and click finish. We can see our newly created role. Head over to AWS Lambda service. Click create function, choose author from scratch, name function to my function. From runtime, select Python 3.9 or any newer version. Remember to expand change default execution role and choose use an existing role. From the drop down, select our recently created role. Here you can see some advanced settings as well. Click create function. Now our Lambda function is being created and it says successfully created. Scroll down to update the code. Head back to our secret, scroll down and grab Python 3 code snippet. Select all and copy. Paste code snippet in lambda function.py. At the end of function, which is get underscore secret, add return secret statement and rename decoded underscore binary underscore secret to secret as well. In the lambda handler function, add a string to send secret credentials in the response body for testing purposes. You can see some information here which will be used to identify our secret. Hit deploy button. It successfully deployed our updated code. Now click test, name the test event as event test 1 and click save. Hit the test again and here is the output of our function. We can see key value pair in stringify format. To convert it in JSON format, we have to go back to code and apply json.loads and access our API key from the dictionary object. Hit deploy and now click test. Oops, I mistakenly wrote API underscore key instead of API dash key. Let's change that in code and redeploy. Now, after hitting test, we can see the API key value, which is random 123456 dash API dash key. Let's head back to secrets manager, scroll up and click retrieve secret value. Click edit and change value to random 123456 dash API dash key dash random and click save. Test Lambda function again and here we can see the updated API dash key value. We can delete the secret as well. The minimum retention limit is 7 days and max 30 days. We can change it to 7 if we want to delete. That's all for today's video.